Okay, so Gerard, today we're just going to start, if I may, by asking you if you can remember that far back, and I don't mean to be rude, but you're similar age to me, so you've had a working career for quite some time, but it'd be great to share, your career path up until, currently where you're now at Kao Data.
Yeah, sure, yeah. And it does go back quite a long way, back to 1979. So I was actually a 16-year-old school leaver, joining a 4-year apprenticeship with, sadly, one of our long-lost businesses, Lucas Electrical in Birmingham. I'd specifically, and this is relevant perhaps to later on in the conversation, I'd specifically wanted to leave and do a vocational-based training route into the industry as a general, and this was not the data center industry at the time, but into electrical engineering through a 4-year indentured apprenticeship. So, it was all contracted, you had to be there. And through that, I sort of really developed the engineering skills that I'd sort of been inspired with, both at school and in my own sort of personal life. I guess my real sort of interest in electronics started when I was about 8, when I got one of those kits where you build up little circuits. And from that time on, really, I've been committed. So here we are now at the age of 60. Not a lot has changed, and I've sort of fulfilled some of those dreams, which has been good. I then left the apprenticeship and did a full-time degree in electrical electronic engineering. Number of little jobs sort of going through, and led really into a career in sort of heavy engineering, sewage treatment, but focusing on BMS effectively, but telemetry it was called in those days. And that really led me by chance to an opportunity with Richard Ellis, who was getting involved in mechanical electrical advisory on their sort of real estate brokerage side. And got involved with a new project, which was Global Switch's first building down at East India Dock, turning the Financial Times print works into a data center, a hosting center. Initially, by Andy Rowan at the time, earmarked to be an IMAX cinema. So it's interesting how the markets have changed. So I spent some time with Insignia Richard Ellis from Richard Ellis as they got invested in. The first project was at Global Switch that I was involved with, building part of Global Crossing's pan-European network, starting in 1998. So the first sort of 20 years of my career have been in more sort of general engineering. It's the last 24 that have been data center specific. Global Crossing at the end of a very successful project there, developing around about 112,000 square feet of space for them. I then actually got poached by Global Crossing to set up Global Center and their web hosting type offering in the market, rather than the communications side of the business. Spent a very short time there before the bust in 2001, when everything went completely haywire, and tracked back to CB Richard Ellis at the time that occurred. And again, working very closely with clients, built up a good relationship with Digital Realty, and got asked to go and join them to set up their operations in Europe, as employee number 4 out of what has ended up being a very large organization globally now, and held the role there of VP of design for, I guess, 11 years, right up until 2017, when I was approached by Kao Data, actually an ex-employee of mine, asking me to come and bring that experience across to Kao Data, which was itself founded in 2014. So still relatively small and entrepreneurial at the time, and engaged to the rest of the market is still relatively small in terms of its footprint and size. But But yeah, here I am at Kao Data, sort of ending that 24-year run of data center experience.
Okay, and in terms, I mean, would it be possible to pick a few highlights from what you've done in terms of, you know, the things you particularly enjoyed, or, you know, innovations along the way? And also, I mean, I'm sure you wouldn't want to name names, but were there any sort of frustrations as well you sort of bumped into
Yeah.
along the way?
There are always frustrations, but I suppose, to use a bit of a cliche, frustrations actually help you create opportunities. So it sort of focuses the mind. I guess one of the real high points was actually on the first project I did for Global Crossing, and at the opening launch for that building, we had Tim Berners-Lee open the session and did a tour, and he was very complimentary of the facility. But you know, to have someone so involved in the World Wide Web opening the thing, talking to us about what we'd done, but also giving us a bit of an insight into the future, which is starting to come full circle. It's slightly outside of his predicted range. So 99, he sort of predicted that in 15 years we'd be seeing sort of light switching, so photons and so on. Interestingly enough, Kao Data, trying to sort of push the boundaries and keep ahead of the curve. We actually had a sort of introduction to quantum computing at our facility in Harlow only last month. Oh, I'm sorry. Where a company called Orca is launching a range of quantum computing equipment, which essentially is photon switching. And really, although we're now 22 years on instead of 15, still the vision of Tim looking at how computing would change, and it'll still be obviously some years before that really comes to fruition, but that will revolutionize, I think, data centers, because the amount of waste heat being generated by that light switching is going to vastly reduce. So it will change how we structure the power and the cooling to the spaces relative to the number of computing operations. But it will be some time. So I don't think we should all panic that a data center that's designed for 5 kilowatts per meter squared today is going to be suddenly redundant, because some of it will be complementary. So we'll have some heavy usage GPUs, CPUs working in conjunction with quantum computing, which are probably sort of less than a kilowatt per meter squared. So, you know, there'll be trade-offs, I'm sure. Whether we get to the point that everything's photon switching, who knows? That's something people can crystal ball gaze for a lot longer than I'll be even on this earth, probably.
In terms of I mean, you've alluded there to quite a significant sort of change in terms of, I guess, the compute, which obviously then impacts the data center. Are there any other sort of massive changes you've observed? I mean, the industry seems to, you know, evolution seems to be the watchword for a long time, and then maybe there is something that changes the whole game a little bit. Yeah. Just thoughts as to what big changes or yeah, important changes you've seen over the period.
In some ways, actually, I find it quite sobering that what we're doing today hasn't really changed that much from what I was doing in '98. To be honest, it's still largely, whether they're crack units, whether they're indirect air units, whether they're whatever, but it's a method of extracting heat from a room that you've put a load of servers in with some UPSs and some generators to back it all up if the grid goes. It really hasn't changed that much. So it is more of a sort of gentle evolution, I think, that we've seen in the data center market. But one of the key drivers for the changes that we've been able to build on, really, and utilize, really to drive efficiency, and Kao Data is really sort of focused on that, and I've been focused on that for a long time. And that was the introduction of the ASHRAE revised operating parameters out of TC 9.9, which thankfully, we've been very lucky that Paul Finch, my chief operating officer, he sits and has sat on the voting committee for TC 9.9. We've managed to stay really in step with what technology is doing. So when you get that sort of recommended envelope that has evolved compared to what I regularly saw back in the sort of 98, 99 sort of time frame, where we used to chuck air in at sort of 18 degrees into the room, have it feeling like a fridge. And because everything was not segregated in terms of airflow, you just got a general mixing, and you got maybe 22 degrees in the room, and the servers would work perfectly happily. But that's such a waste of energy to do that. You know, targeting this 24 degrees, but in a window of 18 to 27, meant that we could really focus on using free cooling. So going up to that 27 recommended limit, I mean, we've still got further opportunities if customers are happy to use the allowable limit. But having that freedom to work in that industry established window, and the advent of hot or cold aisle segregation, really has allowed us to drive up efficiency. You know, for instance, at Harlow now, our campus there, we're using everything is based around indirect air. Does use some water in the summer periods, and perhaps I'll touch on that later, because using water I don't think is holistically a bad thing, but you've got to look on things on a sort of case-by-case basis. But allowing the temperature in the room to rise to 27 before people suddenly get alarmed about whether it's going to be bad for their server means that we've been able to use free cooling for huge amounts of the annual weather trend. If you look at the UK particularly, where you've got an average of probably 12 degrees across the year, between that and 27, you've got a huge sort of envelope to play with in terms of not having to chill and use chillers, which is compressing liquids, which is lots of energy. You know, it makes absolute sense. So we've been able to use indirect cooling, which for a large part of the year, at least 6 months of the year, runs dry. So it's literally a set of fans one side of a heat exchanger, set of fans the other side in the data hall space or technology suite, circulating air, losing that conduction across the heat exchanger and expelling it to atmosphere. And it's as easy as that, and that's allowed us to operate at sort of 1.2 and even give guaranteed SLAs of 1.2 PUEs. So we're definitely market leading on that, which is a key sort of sustainability driver. You know, if you can reduce the amount of energy you're using in the first place, all the other bits become incremental then in terms of where you source it from, how you use water. You know, it's all part of the relatively complex, I guess, conundrum about trying to be as sustainable as possible. Yeah.
In terms of the sort of, so that's the sort of the changing. That's, I guess that's not so much technology, but just you know, an understanding that the temperature envelope can be, you know,
operating
broadened.
conditions. Yeah.
But in terms of the actual technology things, I'm wondering. I don't know. You know, automation, I suspect over the time you've been in data centers, begun to have more of an impact. I don't know. Liquid cooling's been around, then sort of, you know, disappeared for ages and then come back. Just any innovations, and also, I mean, anything else you think is still perhaps, you know, still needs to happen to help improve data center performance, or are we, you know, pretty much there?
Well, I think the key to data center performance is really going back to, if you like, the employer's requirements, the employer, really, the customer. So what do we as a society want from our data centers, from our IT performance? That's got to be the real driver. Expectations are that it's 24/7, never stops. Do we need that for every application? If we've got applications where we don't need that, it gives us opportunities for moving away from having diesel generators on site. If you don't need everything backed up 24/7, 365, if you have a few seconds break when you move, or milliseconds break as you move workflow to another station, does that matter? So that's I guess, one element we really need to address is, what as society are we driving? Now, clearly, COVID in the last few years has shown us that actually digital platforms such as we're using today with Zoom, I think it is, but Teams, Google Meet, all of these platforms have become so much more useful in getting efficiency out of people working. That's a great thing. But, if it wasn't available for a few milliseconds, is that a problem? I mean, I regularly have problems either on Wi-Fi or whatever, and it doesn't really affect the overall benefit of it, but could change the way we build data centers if we thought about it. I think the next thing to look at is the way people write applications, in terms of the failover capability and resilience of the software, but also the efficiency of the software, so that we're trying to address the one of PUE even before we get to the data center infrastructure that's built around it. So that's something I think I'd be really keen to see focused on as we go forwards. But in terms of real innovation in data center infrastructure, I don't think there's been huge steps, if I'm being honest, in those 25 years. Yes, we've seen the advent of better UPSs. We've gone away from transformer-based UPSs, which have got additional losses in, to transformerless ones. We've seen 96.4% efficiency for a while. We've actually employed a new design, which is a modular design. I'm not going to advertise it on the call, but we're up to 97.3% in online mode now. Yes, you can go into offline mode if you like, or eco mode, but online mode, we're at 97.3%. So that 0.7% over a campus like we've got at Harlow of 36 megawatts is quite a real saving of energy. So that's important, but is it completely revolutionary? No. I mean, the UPS has just evolved gradually, and we're on those sort of diminishing returns, I think. Cooling equipment. We made a change at Digital Realty, and that's one of the things that I've had the benefit of in my career, is being able to play in the sandbox continually. We regularly had 7 data centers on the go, and in my period of 11 years there, I built 80, responsible for the design of 80 data suites across 24 facilities, 15 of them new builds, spending in the region of $850 to $1 billion worth of Digital Realty's money. And that's great because it gives you that ability to continually improve. You're tweaking little things at each time, but I think out of all of those 80 suites, only 2 were identical. Everything had a slight improvement, or certainly set out to be an improvement. Proof of the pudding is obviously seeing how they perform, but it's very incremental. I don't think there's been anything that has changed dramatically, if I'm being honest. Yeah.
And in terms of where you are now, I'm guessing Kao Data are lucky folks in the sense they're benefiting from what you've just explained. With your career to date, if you like, you've been able to bring all of that with you, to help them, design and data centers, operate them efficiently, etc. So just be good, I suppose, that if you can summarize, what you've sort of learned along the way that's meant you can help Kao design the sort of data centers which I know they have a great reputation for sustainability, efficiency, etc. So yeah.
Well, I mean one of the key things is working very closely with other teams, that intercommunication. So I've had the benefit of working with Paul Finch for probably literally together for 15 of the last 17 years, and he's been responsible for operations and I've been responsible for design at Kao Data. I think that it's got to be an intrinsically linked design and operations based approach to building data centers. You've got to understand how a data center is going to operate and build that into the design to make sure you're getting the right efficiencies and so on. It was something that Paul and I established at Digital Realty. We had regular meetings between operations and design. And it's absolutely key that we keep that. And because of that, hopefully part of my legacy is that my team have been putting together a basis of design document that documents everything that we've done over anything over my career, which has been built into the Kao product now. So I guess we've taken the cream of everything and tried to refine it so that we've got a playbook of building the most efficient data centers, hopefully the most sustainable data centers. Whilst we're still using diesel generators, rather than using fossil fuel diesel, we now use hydro-treated vegetable oil. In reality, with the stability of the grid in the UK, we don't actually run generators very much. But for the time we do, we know now that we're not using fossil fuel. We're using a recycled product in the first place. The product itself is grown on a 12-month cycle, and the oil collected used for cooking first. It generates 90% less greenhouse gases emissions, 6% less NOx emissions, and 13% less particulates. But it's been great that between operations and myself, we've been able to trial these things, do the testing, do the due diligence, prove that it works, and then make a decision to go ahead on it. Even where that sustainability sort of lever costs you a little bit more. So HVO fuel, for instance, is probably about 15% more than fossil fuel, diesel. But in absolute terms, it doesn't really affect the operating cost that much because we run so little in the year. It's just testing hours. Now, clearly, if we had a major blackout, then that would change. But I think we probably have huger things to worry about than the 15% on fuel. Interestingly, at times this year, one of the big changes we've seen is the cost of energy. And at times, it's actually probably been cheaper to generate our own electricity with HVO than take it from the grid. We've not done that because obviously with a medium combustion permit, you're only allowed a sort of 24-hour operating window in a year. So we couldn't do that as a base, but you know, it's certainly something to be looking at. This whole energy mix, I think, is going to come into real scrutiny, I think, going forwards with data center developments. And again, one size fits all globally is never going to work. We've got to look at how we take the best of PV generated electricity, wind generated electricity, hydrogen generated electricity, perhaps, gas, nuclear, and put that mix together to get the best overall carbon footprint for data centers. We're committed to trying to get to net zero, and we are trying to do that by a number of ways, and we do sort of offline projects. So we've been looking at hydrogen fuel cells, we've been looking at PV farms. We've currently got 100% REGO certificate power supply, which takes power on an annual basis solely from one wind farm. But of course, when it goes into the grid, you don't know what electrons you're actually drawing. They only sort of certify that on a 12-month basis. But we should be driving towards getting 24-hour carbon-free energy. But reducing the amount we use in the first place is critical. So hence me bringing up the issue around writing software more efficiently. The usage of water in some places is an absolute no-no. You know, there are places in this world that have got very stressed levels of water. But where we are in Northern Europe, at Harlow, for instance, we use something like 8,300 litres of water to save a megawatt hour of energy on site by reducing our PUE effectively. However, if you took that energy, that 1 megawatt hour from the grid, most power stations will be using in the region of 85,000 litres of water to generate it. So actually, we've used far less water holistically. And yes, there is still some embedded carbon in getting the water to your data centre. But I think this is where you've got to use a lot of probably processing power and AI to look at what model suits a data centre in a particular location. And I think as we go forwards, we will see in data center operations also analyzing things like predictive maintenance, a lot more machine learning rather than artificial intelligence perhaps, but computers actually looking at the data being generated by BMSs to trim where we buy our power from. You know, maybe we'll be looking at aggregators that have service level agreements, so we actually buy power as a service rather than taking a firm connection off the grid where you really have no control whether it's on or off. Yes, they have KPIs and targets, but you can't go back and back to back an SLA with the grid. Maybe we need people who can do SLAs so that actually we could strip out generators from our data centers. We could strip out UPSs because all of that resilience is built into the aggregation service. Yeah, lots, I think a lot more sort of intelligence will have to go into data centers and how they operate. And I think we've got that with the ability to sort of look at high power computing and so on.
And bear in mind, I mean, what you've discussed, and you sort of looked at some of the high level things, as you say, we've got to decide what we want from data centers at one end of the spectrum to all the sort of technology we can put in there. Are you sort of optimistic, if you like, and positive about the data center? You think the data center energy should be fairly, proud of what it is doing and what it can do, or do you worry that we're in danger of being attacked and we need to be defensive rather than, how do you see the data center industry's future? Is it going to get loads of brickbats like, say, the airline industry because of the carbon footprint, or will people understand the nuances that a lot of activities that are underpinned by data centers are actually saving huge amounts of carbon at the same time, obviously, as they are consuming some energy along the way? Just your thoughts on that sort of complicated future.
Yeah, no, and it is very complex. So I think it would be remiss of me to say that I can give you a one-word answer that solves everything. But yeah, I am very positive about the industry, and I'm positive about the future of it. I mean, one of the things I want to do as I retire is actually work in as a STEM ambassador to encourage people to get into engineering in general, but I will certainly sort of emphasize the requirements and also the interests that are driven by the data center sector. But I think we should be positive about it. The meeting we're having here, if you and I wanted to do this face to face, I'd have had to come to London or vice versa. That would be a whole load of other carbon. Exactly whether it trades off, who knows, because it is so complex. So I think we should be positive about it, but I certainly hear your sort of perhaps concerns that there will be always a negative sort of given to the industry. We see it in newspapers where we can't develop houses in London because the shortage of power, or Thames Water are saying there's data centers use too much water. They also neglect to sort of point out that they lose 3.2 billion litres of water every day because of the leaks in the system. So, everything has to be scrutinised really to get a proper level playing field. Aeroplanes, for instance, yes, use huge amounts of fuel, but do we see people not wanting to fly? No, unfortunately, we as consumers want a lot of these things. So I think we need to look at the most efficient way of doing them. And I think, digital transformation, digital business is a pretty good way of doing business, to be honest. Meetings like this, I have regular meetings with all of my team that otherwise I'd be traveling to different places to do. When I was at Digital Realty, we used very little of this, to be honest, and the amount of air miles that I used to do was enormous. my carbon footprint from travel these days is far reduced. So I think there are many positive benefits. Paying bills. I don't go to a high street bank now to pay bills. I remember in the early days working with George Rocket and Emma Fryer, and thinking about what benefits do we get from the digital transformation. We were trying to think, how do you actually classify how many trips to the high street have you saved? And it's almost impossible, I think, to actually calculate. But I think my gut feel is that digital helps us in our business and social activities. I mean, it'd be interesting to analyse the people that complain about sort of the usage of energy and so on, how they report it in the media. I'm not going to say any more than that, but but even if we go back a whole generation or so, or even now, a steel plant in the UK or Western Europe that's technically advanced probably produces steel with a far smaller carbon footprint than one maybe in a developing country. Those sort of things need to be looked at. We should always focus on using the minimum resources for every process we do. It takes a lot of time and thought, but that's what we should strive for. And ultimately, it does have to be balanced against cost, because most of all of these developments are being funded by somebody who wants a return on the money. So, you've got to balance those things. But we certainly shouldn't be greenwashing. We should be fully committed to driving sustainability for our own planet and society, rather than just focusing on investor returns, I think.
And you mentioned there that you are planning to become a STEM ambassador. So
Yep.
I'd be interested in terms of there aren't enough, clearly, people looking at the industry or wider technology, I guess, for a career. But what sort of things would you say to someone, who is maybe, or, has at least got a bit of an interest? How would you convince them or excite them about, the opportunities and what they can get up to in this space?
I think, if nothing else, just the whole life experience, the number of people that I've interacted with over my 44 years in engineering, but specifically the last 24 in data centers, has been enormous. The ability it's given me to travel around the world and see how different people work, but more importantly, talking to and listening to customers about what they need to drive their business, and then taking that away as a requirement to come up with a system that meets a cost, meets a delivery program, and all the rest of it to fulfill that need. I think it's, to me, and it may sound sort of weird, but it's so exciting, I think, to be able to look at those inputs, design something that uses the minimum amount of power, minimum amount of water, minimal amount of resources, and achieve something that other people perhaps spend twice as much money on. That value for money, sparseness of resource, using that innovation sort of process to sort of look at things and truly value engineer. I think, often I've worked on programs where people have said, oh, we've got to VE this, we've got to VE this. Value engineering really means creating something that gives you the same output with reduced input. Often VE is used to say scope cut and save money, and they're two completely different things. True value engineering really means using initiative, using innovation to design something in a completely different way, but to achieve the same ends. And that I find extremely exciting, and has driven me through the last 24 years. It's flown by, to be honest. So that's the sort of thing I'd want to stress to people coming into it. And there's such a wide range of roles to do within the data center sector, all the way from operations through to, fairly mundane design process, I guess. But, it really is very encompassing. And what we should do is encourage everybody from every background and, you know, across the whole spectrum and be fully inclusive. You know, we should be getting the right people in to do the right jobs and make it sort of merit-based, and hopefully we will be inclusive in that process.
Okay, we covered a lot of ground and given us some brilliant thoughts and insights, Gerard. So I really appreciate the time you give me. Thank you very much indeed. Thank you.
Thanks very much, Phil. Cheers.